And on to the final set of 3 questions. I know that this particular question caused a number of issues. A rectangular floor tile is shown. Its dimensions are given to the nearest 0.1 metres. The tile is only able to sustain a maximum pressure of 200 newtons per square metre, correct to the nearest 5 newtons per metre squared. Given that pressure equals force per unit area, that will be given in the exam. Work out the maximum force in newtons that can safely be applied to the tile. The key words here are bolded for you, maximum and safely. The one people seem to be missing is safely. So what they're asking you here is which force, like what's the highest possible force that you know will definitely be safe. So you need to consider the worst case scenario here, because you need to know it will definitely be safe. So force is equal to pressure times area. So you need to know if it's definitely going to be safe, that would be if my floor tile actually could take the least pressure possible, so 200 newtons per square metre to the nearest 5 newtons per square metre. So that would be 197.5 newtons per square metre times the area. And that situation, once again, that force would be lowest if my area was the smallest. So the dimensions are given to the nearest 0.1 metres, so my area then is going to be 1.55 times 2.25. Now just to recap why I've used all my lower bounds there, it's because we need to know that it's definitely safe, and therefore we need a force that is going to be definitely safe. So if my tile was as small as possible and could take the least pressure possible, what force would still be safe? That's what we're working out here. And then it's just a simple case of typing into your calculator. So 197.5 times 1.55 times 2.25 to give you your area gives you a force of, let's go 3SF, 689 newtons. The next question. The length L of a steel rod is 7.36, correct to 2 decimal places. Complete the error interval for length L. The error interval is just, if we know it's 2 dp, what is the range of values that it could assume? So it could be 7.355, and it could be equal to that as well. And it could go up to 7.365, but it couldn't be equal to that. Now that resolves a lot of the problems you often have when you first learn about upper bounds and writing it at 7.365, because this equality is with what you expect. And the only reason our upper bound would still be 7.365 is that 7.364,99999 going on forever is the same thing. Final question of the test. I believe it's one you'd even seen before, so that's my mistake. The driving distance between Manchester and London is 195 miles. Faris intends to travel from Manchester to London by coach. The coach will leave Manchester at 3:30 p.m. Faris assumes that the coach will travel at an average speed of 50 miles per hour. Using this assumption, work out Faris's arrival time in London. So the first thing we need to do is work out how long it takes to do this. So 50 miles an hour and 195 miles means it's going to take 195 divided by 50. How many times does 50 go into 195? Hours. So it's going to take 3.9 hours. Now it's important to remember here that there are 60 minutes in an hour, so that's not 3 hours 90 minutes, right? In fact, that's going to be 3 hours, and then 90% of 60 is 54 minutes. Then we need to add that on to 3:30 p.m. So adding 3 hours is nice and simple. That would take me to 6:30 p.m. Adding 54 minutes would take me to 7:24 p.m. All I did there really is add an hour and take off 6 minutes. And so the arrival time is 7:24 p.m. It actually turns out that the coach has a lower average speed. Describe how this affects travel time. Well, if it has a lower average speed, it's going to take longer to travel, so it increases your travel time. And with that, we've been through the whole end of unit test. I hope that was useful. I would recommend going back now and looking at any questions you got wrong, and without referring to my video or any notes you've made, do that question again and make sure you have that method in your head, because that really will allow you to recall that under subsequent examination conditions. Other than that, thank you.